Hello, so today's speech is on the Curiosity Rover. So part one, we're going to be talking about the purpose, what it does, and how it does it. So it was sent to Mars to determine whether or not Mars has the capability to hold life in the past. So essentially how it would do this is it has a robotic arm that would take samples of the rock, and then in future missions, NASA will send rockets to Mars to collect these samples, ship them back to Earth so we can test these rock samples for microscopic bacteria or for past fossils. So here's an art piece designed by an artist that was created to show the Curiosity Rover drilling out a piece of rock. So for example, here you can see a drill, a small camera, and another little bit. The little bit is the dust collector, which I'll get to in the next slide. Okay, so the robotic arm basically functions like a human arm, so that NASA could program it like a human arm, and so it would be much easier to operate. So it has 5 parts. These 5 parts are to test radiation, which is for future Mars missions, and to determine if Mars had a magnetic field in the past. It has a camera so that we can monitor the health of the robotic arm, and a rock collection system so we can store the rock, a drill system so we can get the rock out of the ground, and a dust removal tool for the camera and for the drill. So next up is life on Mars. So ample evidence has been discovered to support the idea of past life on Mars. However, we're not actually sure if there has ever been life on Mars. We just know that it has certainly been possible for a very short amount of time where there were glaciers and there was a thin atmosphere. However, since we don't know, that's why we sent the Curiosity Rover here. So the rover discovered radiation, which means either there was a past magnetic field or some asteroid collided into Mars with radioactive materials. The valleys and crooks on the surface show us that there were past riverbeds and oceans on Mars, which means essentially that there was life. So next up is how the robot gets its power. Essentially, we all know that robots need electricity, and the way it gets it is by taking the heat energy from the plutonium that they just put in the robot, and it's in a very lightweight and compact shell, so the robot is not encumbered by this, and it's guaranteed at least 1 Mars year of operation. And then, in terms of safety, well, who would want a plutonium, just a chunk of plutonium sitting on Mars? So that's why NASA created this shell around the thing, which I'll explain in the next slide. So here's how it works. Is essentially it's what they call a radioisotope thermoelectric generator. And it creates 2 kilowatt-hours every day. And while the robot is not using this energy, they charge 2 batteries. So when the robot encounters rough terrain, they can charge those 2 batteries so that there's more energy to use. And so it operates via thermocouples and the Seebeck effect, which essentially thermocouples are how they generate electrical energy from heat energy. And the Seebeck effect is basically in this diagram shown above. When there's a heat source, which in this case is the chunk of plutonium, and a cool side, which is Mars surface, it creates an electrical current around the design, which is used to power things because of the moving electrons that are circulating throughout the circuit. Then the waste heat from this is used to warm systems, and that helps with the rover when it encounters incredibly cold or incredibly hot temperatures on Mars' surface. So next up is the transportation, because we all know that rovers have to get around. So it uses a design of 6 aluminum wheels, which the front 2 and the back 2 turning capabilities, and then they're made of aluminum and titanium, so that they're bendable but still very resistant. However, they do have one crippling weakness that I'll get to in the next slide. Essentially, what happens is, although the wheels are designed to maneuver very high rocks that are very sharp, over time they become malleable. And what you can see here is that rocks on Mars' surface begin puncturing these. However, NASA has a campaign where essentially if the wheels become too broken, what they'll do is they'll crash the wheels into a very sharp rock, so the wheels actually fall off, and then they can spend future missions to attach or but cameras. So the rover has 17 cameras, which include hazard avoidance, which is essentially seeing a threat and then moving around it. Navigation, which is just moving around objects safely. Imagery, which is these camera images you can see here. Fortunately, they're not very high quality, but that's the best you can do on Mars, because if they're too high quality and they get a tiny bit of sun in them, since there's no atmosphere, strong atmosphere on Mars, what will happen is essentially the cameras will just break. And then descent imagery, which just records the descent of the rover so that NASA knows if it's safe on Mars. Next up is the body. So essentially the body is what they use to house the 2 main computers of the rover. They have encountered a couple issues with the main computer before, which I'll get to later, but essentially the main computer allows communication and health. So when NASA wants to monitor the rover or control it to do something else, they can contact the computer, and they can also see its position on Mars and all of the states of its crew systems. So when it comes to computers on Mars, the sensors malfunction actually quite a bit, losing attitude in the middle of their tasks. Essentially what this means is it forgets where its arm is, or it forgets where its leg is. So let's say I'm walking and then I forget where my leg is, I kind of just fall over. Nothing bad really happened from this, but far worse things could have happened, like the rover hitting itself repeatedly with its arm, or just self-destructing against a rock, but thankfully that didn't happen. So essentially the rover is a very efficient machine, and although it had a couple flaws, hopefully it'll help us understand Mars better. But next up we're going to do a little activity. I thought we'd have a tiny bit more people, but that's okay. So if you think yes to the following question, I want you to go to this side of the room. If you say no, I want you to go to this side of the room. So do you think there's any form of life on Mars? Okay, so if yes, go to that side. If no, go to that side. Okay, now I want you guys to debate whether or not and why you think that. So you seem to be the odd one out here, so what do you think?
I don't think there's any sentient life, there's probably not any big life either. Any small life like bacteria, I don't think it's possible, just because I don't think there's enough, like the atmosphere doesn't sustain it. And I think if you left like an apple there, it would just stay right, because there's not anything to eat it with.
And then, any of you guys feel passionate about looking it up to share?
Well, I think that they've actually they know about water reserves like the surface, which could possibly be because water is one of the key factors to sustain life. So even if there's not actually big forms of life, there might be single cell